Hi, I'm Mudinda and I'm here to help you understand maths better for free. Today we're going to be looking at completing the square. I'm going to teach you 3 simple steps that'll ensure you get it right every single time. Without wasting your time, let's get into it. We know that we're given quadratic equations in the form ax squared plus bx plus c. Now the very first step of completing the square is to ensure that a is 1. A is the coefficient of x squared. If a is not 1, you'll have to take out a as a common factor. We'll look at that in an example. Now, the second step might sound weird and complicated when I say it, but when we look at an example, it'll make perfect sense. The second step is to find half of b. B is this number. Find half of b, then square half of b. That is our special number. Finding half of b and squaring it gives us our special number, which we then add and subtract to that expression. This will make perfect sense when we look at an example in a second. The third step is to look at the first 3 terms as a separate trinomial and factorize it. Those are the 3 steps. Ensure a is 1, find half of b and square it to get the special number, which we will add and subtract to the expression. Then look at the first 3 terms as a separate trinomial. That's it. Let's look at some illustrative examples. Here we're given the expression x squared minus 4x minus 5, and say we're asked to complete the square. We're going to find half of b. Well, lucky for us, the first step, ensuring a is 1, we don't have to do it because a already is 1. So the second step is to find half of b and square it. B in our case is minus 4. So we're going to take minus 4 and find half of it, in other words, divided by 2. Whatever that gives us, we're going to square it. Now, half of negative 4 is negative 2. And when you square negative 2, you get 4. So 4 is our special number, which we're going to add and subtract. Now, we always add it and subtract it right after the b term. So we're going to say x squared minus 4x plus the special number minus the special number. Now the reason we're allowed to do this is because this is just 0. Minus 4 and plus 4 give us 0. So we haven't changed the expression at all. The last step is to look at the first 3 terms as a separate trinomial, then factorize it. Now, how do I factorize x squared minus 4x plus 4? I'll put x here, x there, 2 here, and 2 there. Now, there is a little trick, particularly on completing the square, that I want you to learn regarding the signs. This sign will always be positive, which tells us that we'll always have the same sign in there. You then look at this sign to tell you whether it will be both negative or both positive. In our case, since that one's a minus, we're going to have minus and minus. Now, negative 4 minus 5 is just negative 9. Since x minus 2 repeats itself, we can write it as x minus 2 squared. This is now the square completed. Let's look at a second example. Here we have x squared minus 6x minus 8. The first step is to ensure that a is 1, and in our case it's already 1. The second step is to find half of b and square it. So that's negative 6 divided by 2 and square it. Now, negative 6 over 2 is negative 3. When you square negative 3, you get positive 9. That's our special number, which we're going to add and subtract. So add 9, subtract 9. We always add it right in front of the b term, right there. Then we look at the first 3 terms as a separate trinomial and factorize it. Now, the funny part is you actually don't really have to factorize. You're just going to put x here, x there, and the square root of whatever this number is here and there. And like I said, this is a positive, so that means they're going to be the same there. And because that's a minus, there'll be minus and minus. Now, negative 9 minus 8, that's negative 17. So since x minus 3 is repeating itself, I can write it as x minus 3 squared minus 17. Now, there's a reason I'm saying you don't technically have to factorize. You just put x, and the square root of whatever this is, and if that's a negative, minus and minus, if that's a positive, plus and plus. The reason I'm saying that is because it does get a bit messy when B doesn't give you a nice to work with number, and that's where a lot of learners get confused. But like I said, even when it's messy, it's not really factorization. You can actually memorize how to do it. I'll show you an example just now. So here are the examples. You have x squared minus 3x minus 10 here. Now, half of negative 3 is just minus 3 over 2. And when you square minus 3 over 2, you get 9 over 4. This is where a lot of learners find this to be tricky. Well, this is just a special number again. I'm going to take it and I'll add it and subtract it right after minus 3x. So plus 9 over 4, minus 9 over 4, and minus 10. Now we're going to look at the first three terms as a separate trinomial and factorize it. But like I said, you don't have to worry yourself about, okay, what are the factors of 9 over 4? That sounds confusing, doesn't it? You simply have to put x here and put x there. Then find the square root of 9 over 4, which is just 3 over 2. Then put a minus and a minus since that's negative. Now, the rest, minus 9 over 4 minus 10, you can put in your calculator. Negative 9 over 4 minus 10, according to my calculator, is negative 49 over 4. So the completed square is x minus 3 over 2 squared minus 49 over 4. Let's look at another example, and let me actually make this a positive because we haven't looked at those. Here I'm going to find half of 5, which is just 5 over 2. And when I square 5 over 2, I get 25 over 4. That's my special number. I'm going to add it and subtract it. Then I'll look at the first three as a separate trinomial. Technically, I don't really have to factorize. I'm just going to put x and x, then the square root of 25, which is 5 over 2 on both sides. Now, since this is a positive, I'm going to put a plus and a plus. Okay, remember we said this is always positive, and that means we'll always have the same signs. And this will tell us whether it should be two positives or two negatives. Now, why will this always be positive? Remember, we start by adding and then subtracting it. Okay, that's why it'll always be positive. Now, negative 25 over 4 minus 14, according to my calculator, is negative 81 over 4. So the completed square is x plus 5 over 2 all squared minus 81 over 4. Now, let's look at an example where a is not 1. So here we have 2x squared minus 8x minus 3. Now, to complete the square here, you're going to take 2 as a common factor. You always take a as a common factor if a is not 1. This leaves us with x squared minus 4x minus 3 over 2. Now we can complete the square in there. Okay. We're going to take half of b and square it. So negative 4 divided by 2 is 2, and 2 squared is 4. So we now have 2 into x squared minus 4x plus 4 and minus 4 minus 3 over 2. I'm simply adding and subtracting the special number. Then I'll look at the first three terms as a separate trinomial. I can now factorize this. I'll put x, 2, 2, minus and minus. Now, according to my calculator, negative 4 minus 3 over 2 is negative 11 over 2. And this then leaves me with 2 into x minus 2 squared minus 11 over 2. Okay, now you need to now introduce this 2 to right in front of the bracket and to that other term over there. So the completed square would be 2 into x minus 2 squared minus 11. Because if you multiply 2 with negative 11 over 2, you'll get minus 11. So that's now the completed square. What about solving equations using completing the square? Let's look at a couple of examples. Say we had x squared minus 4x minus 3 is equal to 0. To solve this equation by completing the square, we're going to follow the same steps. That's where we'll start. We'll say, okay, well, half of negative 4 is minus 2, and when I square minus 2, I get 4. So this is now x squared minus 4x, then I add the special number and subtract the special number. Then I look at the first 3 as a separate trinomial, and I factorize. X, 2, 2, minus and minus. Now, negative 4 minus 3 is negative 7. So now I have here that x minus 2 all squared minus 7 is equal to 0. Now, this is the critical part, okay? I'm going to move this 7 to the other side. I'll say, well, x minus 2 all squared is equal to positive 7, all right? Now, the next step is to put a square root on both sides so I can get rid of that squared there, right? Remember, in this case, we're solving for x, right? But now, please keep in mind that whenever you are solving for something with a squared, like say x squared is equal to 16, don't be tempted to just say, oh, therefore x is 4. No, x could be 4 or it could be minus 4. Every single time that we introduce a square root sign, we must put plus or minus right behind it. So x can either be negative, the square root of 16, which is 4, or it can be positive, the square root of 16. Now, in the same way, x minus 2 is equal to plus or minus the square root of 7. Which means that, therefore, x is either, and I'm going to move this 2 to the other side, or rather, let me start here. X minus 2 is either square root of 7 or x minus 2 is negative square root of 7. I hope that makes sense. And so x is either 2 plus root 7 or x is 2 minus root 7. Okay, so this is how you use completing the square to solve for an equation that can't be factorized. Okay, and this is the exact answer that you would get if you used the quadratic formula. And that's the beauty of completing the square. You're used to everything else we did up until this point, okay? Just remember, you need to move this to the other side. Then when you're finding the square root to get rid of the squared, make sure to put plus or minus there. Okay, let's look at another example. How can we solve x squared minus x minus 1 is equal to 0 using the, let me actually change this question and just put maybe a 3 here. How can we solve for this using completing the square? Well, what is half of b? B is negative 3, half of b squared is 9 over 4. So we have here x squared minus 3x plus 9 over 4 minus 9 over 4 minus 1 is equal to 0. We're going to look at the first 3 as a separate trinomial. Then we're going to factorize. Okay, so put here x and x, 3 over 2 and 3 over 2, then a minus and a minus. Now, according to my calculator, negative 9 over 4 minus 1 gives me negative 13 over 4. This is equal to 0. So now I have x minus 3 over 2 squared minus 13 over 4 is equal to 0. Here's that critical step, right? I'm going to move the 13 over 4 to the other side. So I have x minus 3 over 2 squared is equal to 13 over 4. Now, x minus 3 over 2 is equal to plus or minus the square root of 3 over 4. All right. Which means that x minus 3 over 2 is either positive root 13 over 4 or x minus 3 over 2 is negative root 13 over 4. Please note that the square root of 13 over 4 is the same as the square root of 13 over the square root of 4, which is the same as root 13 over 2, because square root of 4 is just 2. Okay, so I'm going to apply that in this next step. I'm going to say, well, this means x is either 3 over 2 plus root 13 over 2, or x is 3 over 2 minus root 13 over 2. This is just two fractions with the same denominator. So we have 3 plus root 13 over 2, or 3 minus root 13 over 2. So as you can see, this is the answer you would get if you put this equation in the quadratic formula, right? And that's the beauty of completing the square, is it helps us to answer how to solve any equation, even if we can't use the quadratic formula. Say you don't have your calculator or something. Great. Yes, that's it. I hope that this video has been helpful. If you got confused somewhere along the way, I really do suggest that you rewatch the video, take it slowly. Remember, you can watch this anytime. You can watch this as many times as you want. Make sure that you are comfortable with completing the square, because it is not that bad. See you in the next